Let's have a look at question 11. Figure 2 shows a sketch of part of the curve with equation y equal to ln x all square and x is more than 0. The finite region R shown shaded in figure 2 is bounded by the curve, the line with equation x equal to 2, the x-axis, and the line with equation x equal to 4, which is already sketched in here. And then the table below shows corresponding values of x and y, with the values of y given to 4 decimal places. And then part A wants us to use the trapezium rule to find the estimate for the area of R. And then part B, they just want us to integrate it and then to find the exact value of R leaving this form. I see. Okay, let's do part A first. So for part A, we just have to use the trapezium rule to work out the area. So the trapezium rule formula is h over 2. And then y, the first y value and the last y value, we only use it once. And all the y values in the middle, we use it twice. So first we need to work out what h is. So h is just the difference between any two consecutive values. So 2 and 2.5, the difference is 0.5. 2.5 to 3 is also 0.5. And then 3 to 3.5 also 0.5. So like the difference is always the same because we cut it into equal strips. That's why the difference between each two values would be the same. So you can just take the difference between any two values and that would be our h. So put in 0.5 over 2. And then the first y value is 0.4805. And then plus all the y value in the middle, we use it twice. So 2 times by 0.8396 plus 1.2069, and then plus 1.5694. And then the last y value, we only use it once. So plus 1.9218. So now we just put in the calculator. So 0.8396 plus 1.206 plus 1.5694. So like what I'm going to put in the calculator is because there are so many numbers, I'm going to put all this in the calculator first. So once I add all of them and then I times by 2. So, and then once I done that and I plus 0.4805 and then plus 1.9218. So, and then once I work out all of this inside the bigger brackets, and then I times by the one outside, 0.5 over 2. So I find this way easier. So then the final answer, it'll be 2.408075, and they want us to leave us 3 significant figures. So that has to be 2.41 because 8 round up. Okay, part A is done, 3 marks, nice and easy. And then part B, we need to actually integrate it. So since the limit is between 2 and 4, so we just integrate it between 4 on top and 2 at the bottom, ln x squared dx. So every time when you see a ln in the integration, so you always use integration by parts. So we always let u to be the ln part. So u equal to ln x all square, and then dv over dx has to be equal to 1. So you can imagine this is like 1 loss of ln x square. So if we let this one to be u, then 1 has to be dv over dx. And then differentiate this, du over dx is equal to, this is something squared, so we have to use the chain rule. So we bring the power down, and then minus 1 the power, and then we times by the derivative of the chain because it's not x squared, it's ln x squared. So ln x here would be the chain. So we need to multiply by the derivative of the chain. And then, so ln x will differentiate to 1 over x. So this part is done. And then we integrate dv over dx. So v will just equal to 1 integrate to x. That's all. And now we just use the formula. So that would be x times by ln x squared, and then minus the integral of 2 ln x times 1 over x and times by x. So basically uv minus integral of v du over dx. So just times by those two to get what we need to integrate later. And I will put the everything under the limits, which is 4 and 2, in case we forget later. Yeah. And then simplify that, 1 over x times x will cancel out. So just 2 ln x left. So again, we still have ln x in it, so we need to use integration by parts again. So u is again ln x, and then dv over dx we use 2. So differentiate this, du over dx equal to 1 over x, and then integrate dv over dx, so v is just 2x. So now I'm gonna put this in, so that'll be x ln x all square minus, so because this whole thing is integrating by, like, using the integration by parts. So I'm gonna put a big brackets for that. So you have to put the bigger brackets because whatever that is will integrate to what we're gonna have. Yeah. So then that'll be 2x ln x, just apply the formula again, and then minus the integral of 2x times by 1 over x dx. And then x times 1 over x cancels out, just 2. And I will again put a bigger brackets with limits 4 and 2. And then simplify x ln x all square, and then minus 2x ln x, and then minus become plus the integral of 2 dx, which is 2x. We don't need to put plus c because we have limits 4 and 2 on top. So now substitute all the values in. So we just need to simplify to this form at the end. So now we will have, so put in, that will be 4 ln 4 square minus 2 times 4, 8 ln 4, and then plus 2 times 4 is 8 again, and then put a bigger brackets, and then minus 2 times by ln 2 all square, and then minus 2 times 2 is 4 ln 2, and then plus 2 times 2, which is 4 again. And then that will give us 4 ln, so they want everything in terms of ln 2, so we change 4 into 2 square first, and then minus 8 times by ln 4, which is 2 square again, and then plus 8, and then minus 2 ln 2 square, and then negative make it positive, plus 4 ln 2, and then minus positive 4 is minus 4. So now keep simplify, so 4 times by, we bring the power as the coefficient, so that will give us 2 ln 2 all square. And then minus, we bring the power as coefficient, 8 times 2 is 16. And then 8 minus 4 is just positive 4. And then minus 2 ln 2 square, and then plus 4 ln 2. So now simplify this again, 4 is just 4, but 2 square become 4, and then ln 2 square, just ln 2 square. And then minus, so minus 16 ln 2 plus 4 ln 2 will be minus 12 ln 2. And then plus 4 still the same, and minus 2 ln 2 squared. So 4 times 4 is 16, so 16 ln 2 square minus 2 ln 2 square. Then 16 minus 2 is obviously 14, that would be 14 ln 2 square. And then minus 12 ln 2 plus 4. So there's nothing more we can simplify. So this will be the final answer. So in this case, A is equal to 14, and then B is equal to negative 12, and then C is equal to positive 4.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.